So now we are going to discuss about some problems on graphs, right? See here the first one, the displacement time graph of two bodies A and B are OP and OQ respectively. If angle BOX equal to given, angle POX is given 60 degree and angle QOX is given 45 degree. Ratio of their velocities from A to that of B. So this OP represents A body and OQ represents B body. They are asking velocity of A to velocity of B. They are asking. So how to calculate? See which graph this is? Displacement time graph. So displacement time graph means slope of this displacement time graph gives you what it gives? Velocity. So okay. So displacement by time is what? Velocity only now. So based on that velocity, we will do the problem. See here. So velocity is equal to displacement by time. That means what? Slope. You can write even tan theta also. Slope of the curve is tan theta. Okay. Slope of the curve V is equal to tan theta. Slope of M is equal to tan theta. So slope it gives velocities. So VA by VB is equal to tan theta for A by tan theta for B. So what is the tan theta A? Tan 60 by tan 45 degree. So tan 60 is root 3 by tan 45 is 3. So answer is PA by VB is root 3 is to 1 is the answer. Right? Next, go to another question. Yes, go to next question. In the displacement time graph, two straight lines are making an angle 60 degree and 60 degree and 30 degree with the time axis. Ratio of the magnitude of the velocities is given. See here straight line represent here O to A and then A to this is B. Okay, so they are asking magnitude of velocity. See here positive slope. Here negative slope. So whatever it is, they are asking magnitude of the velocity. So magnitude of velocity VA to VB is equal to same tan theta A by tan theta B. Tan 60 degree by tan 30 degree. What is tan 60? Root 3. By tan 30, 1 by root 3. Answer is 3 is to 1. That is the answer. Right? Next, go to another question. Next question. A rocket is launched upward from the Earth surface whose velocity time graph is shown in the figure. The maximum height attained by the rocket is. See here, this is velocity time graph. So see here, rocket is projected in vertically upward direction. So this is velocity and the height there is. Height is also what? From the ground, how much height the rocket is reached. So that is what? Displacement only. So the displacement, how can you get? So this is velocity time curve. So velocity time curve will get displacement equal to velocity into time. So that means what? Area covered by the curve gives you what? Displacement. So area covered by the velocity time curve gives you what? Displacement. So I need to calculate area covered. Area covered gives what? Height. Height is equal to area covered. Now you tell me what is the height? What is the area covered? This is a triangle. So for this triangle, what is the height reached? Till here 120 seconds. So this is in the triangle in shape. What is the area covered? Area covered is equal to H is equal to area covered, that is equal to half base from 0 to 120. That is what base of the triangle into height. What is the height? Up to 1000 meters per second. So 1000. So 2 ones are 2 60s are. So 60 into 1000 kilometers. 1000 meters. So 1000 meters is nothing but 1 kilometer. So 60 into 1 kilometer, nothing but 60 kilometers. So that is the height it reached by the rocket. So rocket reaches the height of 60 kilometers. So that is the answer for this curve. Next, go to another question. So figure shows the displacement of a particle going along this x-axis as a function of time. The acceleration of the particle is 0 in the region. Okay, so see here, this is displacement time curve. So displacement time curve means it's a straight line which is passing. What it represents from A to B? It's a straight line passing through the origin like it is. So displacement, as time increases, displacement also increases. So it's a positive slope. Positive slope means what? It gives uniform velocity. So A to B represents positive uniform velocity. Okay, then B to C, it is not uniform velocity. Then C to A, C to D you see here, is also uniform velocity, but it is decreasing. So negative velocity, negative slope. This is positive slope. So here also uniform velocity only. V is constant for C to D and A to B. So here constants A to B, for A to B, V is constant, positive value of constant, then acceleration will be 0. Similarly, C to D you take, then also you are getting speed, velocity is constant, then negative value of V, negative constant, then acceleration 0. So answer is for A to B and C to D. A to B and C to D, these two represents uniform velocity, but acceleration is 0. So acceleration is 0. So answer is A, B and C, D. So both A and C. So second option is answer. Right? Next. Go to another question. Yes. Next question. Ratio of displacement or distance covered by a body in 5 seconds. Body is projected. So a particle or a body. So for that they are asking ratio of displacement to distance covered by the body during the 5 seconds. So now you see here. This is what which graph this. 1 second. This is velocity time curve. Okay, so for this velocity time curve, they are asking ratio of displacement to distance curve. Okay, now what you need to calculate? This is a triangle. So here, what is this velocity time curve? How can you calculate the displacement of distance? This is what displacement. If you want to calculate the area covered for this VT curve, gives you what displacement. So displacement is equal to V into T. So this equal to distance equal to velocity into time. Displacement equal to velocity into time. So that means what? Product of these two quantities means what? Area covered. So if you get the area covered, so that gives you what? Displacement and distance in this curve. So you need to calculate area. So but one thing you have to observe, this is what positive area is there, here negative area is there, here positive area is there. So if you take all value positive, this is positive, this is negative and this is positive. If you calculate the area, if you add the areas, then you will get the displacement. But if you take the negative value of the displacement also as positive value, then you will get the distance. That is what the difference between distance and displacement to calculate from the graph. Okay, so displacement to calculate displacement. Displacement is, this is what positive area. What is this triangle? So for this triangle, half first point triangle for this A triangle, B triangle, C triangle. For this area covered SA, SB plus SC. So all are vector one. So the displacement covered for A. What is that? Half base into height. So half base from here to here is 3 into height 2. From here to here, the height of the triangle is 2 units, 2 meter per second. 2 gets cancelled, 3. Then plus area covered by the triangle B. So this is what this is under minus VT graph. So area covered is equal to half. What is the base from 3 to 4? 1 second only. once again into height. What is this from here to here? It is -2. So you are taking -2. Observe it carefully here. -2 you are taking. Instead of taking -2, if you take +2, you get the distance. That's all. So area here, if you consider half base into height is you are getting negative value. So that this area will be -1. So you get here -1. Next, instead of -1, if you take +1, that is the distance. That's the difference. So distance displacement for triangle C. So triangle C means this is what this is what rectangle square type. Okay, from here to here it is 1. Next again here also here to 1. So length into breadth. So what is that? Length is 1 unit, time axis is 1 unit, and velocity axis 1 unit. So how much you get? So 3 plus -1, 1 into -1, -1 plus 1. So -1 plus 1 gets cancelled, you get 3. So this is what? Displacement. Next, distance. Distance you are taking modulus of all the values. Modulus of displacement covered by the triangle A plus triangle B plus triangle C. You know that for triangle A, you got half base into height. Half base into height. You got what? 3. Plus, this is what for triangle B, you got -1 plus 1. Okay. So, you are taking 3 under modulus -1. Modulus of -1 is +1. So, 3 plus 1 plus 1. Totally 5 is the distance. Now they are asking distance to displacement to distance ratio. They are asking displacement to distance. So what is the ratio of displacement to distance? Displacement by distance is equal to, what is the displacement you got here? 3. Displacement you got 3 units and distance you got 5 units. So 3 by 5. So 3:5 is the answer. So second option is the answer, right? Next, go to another question. What is this displacement? Time graph of a particle moving along a straight line. The average velocity of a particle over 10 seconds is shown in the figure. Okay, so now what they are asking, over the 10 seconds they are asking average velocity. So what is the formula for average velocity? Average velocity is equal to net displacement by total time taken. Net displacement by total time taken. Now, what is the displacement here? Starting point is for displacement time curve. See here, displacement started from when t equal to 0, it starts from 60. Next, as time increases, its displacement come to 10 meters when it is at 6 seconds. Next, when it comes to 10 seconds, the displacement of the particle comes to 40. So, final position displacement equal to final position minus initial position. Finally, the particle after 10 seconds comes to 40 meters. So, final position is 40 minus initial position is what? Initially it started from 60. So, 60 by total time taken what? From 0 to 10 seconds is the total journey time. So, 10. So, how much? Minus 20 by 10. 0 got cancelled. So, minus 2 meters per second. So, out of given options, magnitude is there. So, the answer is 2 meter per second. So, average velocity, magnitude of average velocity you are getting here what? 2 meter per second. So, direction, if you speak it, -2 meter per second, correct value. But out of given options, -2 is not there. So, numerical value, magnitude of it is 2 meter per second is the answer. Okay. So, this is about this one. Next problem, we'll see. Yes, see the next question. Figure shows there is a displacement position time graph of a particle moving along a straight line. Okay, which one of the following graphs show the PT graphs of the motion of the body? See here, this is a position time graph. Position is changing by changing the time. It's a proportionality. So proportionality shows it's a constant slope. Constant slope means if the particle is going with uniform velocity. So velocity is constant. Velocity constant. Positive value of velocity constant. Next, here the position of the particle remains same. So that means from 5 to 15 seconds, the particle at rest position. Rest position shows from 5 to 15 seconds. Next, then 15 to 20 seconds, the particle is going in reverse direction. So the displacement is see here. Displacement is going to again coming back to 0. So that means what? Position of the particle is from some x2, it is coming to 0 during that 15 to 20 seconds. So that means here it will have negative slope. So negative slope. Negative slope in the sense what? Particle is having negative velocity. Negative velocity. So negative velocity. So now you observe from where to where it is positive velocity, constant velocity. It is also constant velocity. See here, there is positive constant velocity. Velocity is 0. Rest means velocity is 0 up to from 5 to 15 seconds. Velocity is not there. Velocity is 0. But from 0 to 5 seconds, positive constant velocity is on same value is there. Again after 15 to 20, again same value, but it is going with negative velocity. So you observe here. If you observe all the graphs, see here velocity from 0 to 5. Here it is increasing. But here constant velocity. Velocity is constant. Next, again second point you need to notice 5 to 15 velocity is 0. So this is all graphs are velocity time graphs only. So if you observe that velocity time graphs between 5 to 15, the particle is at rest. 5 to 15 particle at rest. 5 to 15 particle at rest. Here also 5 to 15 particle at rest. 5 to 15 particle at rest. All graphs are showing 5 to 15 particle at rest only. But you see next particle. From 0 to 5 it is positive constant velocity, steady some maximum value, some value. So that is fixed value. So that means like this it's a constant value, either this or this. So you can observe either third graph or fourth graph you can represent the answer. Okay, see here. Here velocity is steady constant value. Here also velocity is constant value. Then here velocity from 5 to 15 it is 0. So here also 5 to 15 is 0. Next. From 15 to 20, velocity is negative value. Here, 15 to 20, velocity is positive value. Here it is showing positive value. So this graph is not the answer. Then you can see that the velocity is negative value. Here, we are getting some negative value, minus. So the answer is fourth graph. Okay, next, we go to the next one. Which of the following meeting graph shows that the realistic situation of our body in motion? See here, this all are velocity time graphs only. So you should know one point here. So that is what? Velocity time. So time cannot be negative. Time cannot be negative. So that means here the particle is shifted. So the particle position is, so time increasing. See here, time is increasing. If you observe here, at one instant you are noticing different velocities. Okay, next. Here also you observe. At a particular instant you are finding different velocities. Here you observe, anywhere you take. There are at one time you are not finding different velocities. Here at one instant you are finding different velocities. Here also. Here also if you take at one instant here one velocity, here also another velocity. Okay, so this is not possible. Even this is also not possible. Even this is also not possible. And this is the correct answer. Realistic situation. Time cannot be negative. Even that point also you can explain. So time cannot be negative. See here. See, as time increases, our velocity you see, time cannot be negative. Cannot be negative. So if you observe, suppose the particle is going in this direction, it is coming like this. But here if you observe, it is going showing negative time from here to here. Again it is showing the same time only. So it is not possible. You are finding different velocities at same time. Here also you are finding different velocities at same time. This is not possible. Here at different velocities at different instants. So this is possible. Here at different velocities at the same instant you are finding. So this is also not possible. So the answer is B is the answer. Next, go to another question. See, next one, acceleration time graph of a particle moving along a straight line is as shown in figure. At what time particle acquires its initial velocity? So that is one question. See here, this is what time curve, velocity, acceleration time curve. See here at what t equal to till t equal to 2 seconds, acceleration of the particle remains 4 meter per second square only. Up to that t equal to 2 seconds, it is maintained steady only. That means the particle is started from the horizon, right? We are finding that up to 2 seconds, we are finding the final velocity. Whatever the final velocity you are finding here, that final velocity will be the initial velocity for next case of retardation of minus 2 meter per second. Okay, so till here you can find the velocity of the particle. So what is that? It gives velocity v is equal to u plus a. Okay, see here, acceleration time graph. Vt, velocity of the particle at t equal to 4 seconds. Velocity at t equal to 2 seconds. Then v is equal to, here v equal to, for positive acceleration, v plus 4 meter per second. V is equal to u plus at. So see here, u is what? U plus at. A is what? 4. For how long it is acting? For 2 t equal to 2 seconds. So u plus 8, that is the velocity here when it reaches t equal to 2 seconds. That will be the initial velocity. This is one. This is the initial velocity for the next case of retardation. Okay, so here after a time t seconds, I need to calculate Vt, that is for second curve. So Vt is equal to V for second case after a time t seconds is equal to same u plus at. What is u here? The final velocity of the first particle only V1. V1 only u. So okay, so what is that? U plus 8, that is u plus at plus what is a? A is minus 2. How long it is acting? We don't know. That only we need to calculate. So this is what Vt, and this is equal to, they have given for yes. See here, V of t is equal to u plus 8. That is the initial velocity. The final velocity acquired by the first graph. For this u plus 8 plus minus 2 into t, that is what? Velocity at t seconds. Okay, this is what second condition. So what is this velocity at t seconds? That should be equal to the initial velocity. So what is the initial velocity here for first group? U. So that means v of t is nothing but given. What they have given? V of t is given like u. So u is equal to u plus 8 minus 2t. Okay. So u gets cancelled. So then after that, you will get 0 is equal to 8 minus 2t. So t is equal to 4 seconds. Wait, this is 4 seconds from here to here. So already this is 2 seconds and additionally 4 seconds. Means total at what second you will get the final velocity? At t equal to 6 seconds. The body acquires initial velocity. The particle acquires initial velocity, that is u. So the answer is t equal to 6 seconds. So 6 seconds is the answer. Okay, so that's about the problems today. Okay.